Since the first road made of stone and wood was built around 4000 BC, the method of building roads has changed a lot. The first Roman road was paved in stone and was built in North Africa and Europe for military proposed road line. A profile board with a fixed height, called the traveller, is used for controlling the excavated levels between operations, through the study of road traffic, stone thickness, road alignment and slope. Road construction technology has gradually improved and developed to use regular, compact design of paving stones and covering with smaller stones to produce a strong layer. Modern roads tend to be constructed using asphalt and/or concrete. Broadly speaking, road construction can be described through three processes: departure, earthwork and paving construction. Set off. This is done in accordance with the dimensions specified in the layout drawing. A profile plate with a fixed height, called a traveller, is used to control the level of excavation between operations. Through the study of road traffic, stone thickness, road alignment and slope, road construction technology has gradually improved and developed to adopt a regular, compact paving stone design and cover with smaller stones to produce a strong layer. Broadly speaking, road construction can be described through three processes: departure, earthwork and paving construction. Set off. This is done according to the dimensions specified in the layout drawing. A commonly used stakeout procedure is the profile plate method. A series of precise horizontal slabs are located 1 meter above the completed construction level, placed at regular intervals along the line these profile boards. By placing the traveller in the line of sight between the two horizontal plates, you can see whether the excavation has been carried out to the correct level and adjusted accordingly. The height of each profile plate is controlled by a wire level, which is a short level suspended on a nylon rope. The line operator moves the string up or down until the bubble is centered. The intersection, hammerhead, bogey, and intersection curve are arranged in a similar manner. Earthwork is one of the main projects of road construction. It involves removing topsoil and any vegetation, then scraping and grading the area until the final stratum level is reached. This is usually done using a tractor shovel, grader or bulldozer. Below the ground, the soil is called the roadbed. Before the earthwork starts, the strength of the roadbed must be tested. Most earthworks are formed by excavation and filling. The type of filling material must be considered, not only its physical properties, but also its use conditions and compaction methods. Depending on its quality, the compressible subsoil may be removed or stabilized. If the cost of excavating all or part of the subsoil is uneconomical and may lead to consolidation, sand cores or sand discharge pipes can be used. Sand core is a borehole filled with sand under the embankment, which reduces the length of water in the drainage path, thereby dissipating water pressure and providing greater stability to the soil. The hourglass beside the road is used to intercept groundwater. Subsoil drainage should be provided to deal with leakage from higher ground through roads and edges, as well as the seasonal rise and fall of groundwater levels. The necessary thickness of the asphalt is controlled by the subgrade strength, so it is alluring to make the subgrade as solid as could really be expected. The strength of the subgrade can be accomplished by utilizing the accompanying procedures: expulsion of helpless material in cuttings and supplanting with chosen fill, compacting subgrade to a high dry thickness, giving satisfactory earth, soil adjustment techniques like the utilization of concrete, bituminous materials or synthetic compounds. The subgrade strength will diminish as dampness content increments, so insurance might be required in the event that it is left uncovered for any period of time. Assurance covering can be all things considered: medium check plastic sheeting with 300 mm laps, and showered bituminous fastener with a sand beating. Once the subgrade has been ready and waste or covered administrations introduced, the clearing development can start. Clearing can be either adaptable or unbending. There are advantages and disadvantages to each sort, with one being chosen over the other relying upon the particular necessities of an undertaking. Inflexible asphalts will in general have lower upkeep costs, a more extended plan life and higher flexural strength, However, adaptable asphalts will in general have lower development costs and have a higher capacity to grow and contract with temperature, thus needn't bother with extension joints. Adaptable clearing comprises of materials applied in layers straight over the subgrade to which the traffic loads are circulated. To forestall lasting disfigurement, and accordingly a lopsided running surface, the thicknesses of individual layers should be fit for disseminating such loads. The subgrade is compacted with its sub-base on top. On top of this is laid the surfacing, which is comprised of the base layer and the wearing course. The wearing course is the upper layer of bituminous material, frequently denser and more grounded than the base layer. The thickness relies upon the material determination and the measure of wear that is normal. Wanted properties are acceptable non-slip abilities, insignificant glare and worthy strength. The principal materials that are utilized are hot moved blacktop, thick bitumen macadam, thick tar macadam and permeable blacktop. DAD is particularly reasonable as it's anything but an open evaluated material that is intended to permit quick, in this manner lessening splash just as tire clamor. The base will commonly have a base thickness of 60 mm and is normally made of thick bitumen macadam or blacktop. It is laid with the fitting crossvalves and slopes. Sub-base. This is set in a layer generally not surpassing 150 mm over the subgrade subsequent to waterproofing is finished. Different materials can be utilized, yet it is entirely expected for squashed stone or dry lean cement laid and compacted by substantial rollers. As of 2009, the United States had the largest road network, reaching 6,518,997 kilometers. The Republic of India has the second largest road system in the world, with a total road length of 4,689,842 kilometers. The People's Republic of China ranked third with 3,583,715 kilometers of roads. The Federal Republic of Brazil has the world's fourth largest highway system with a total length of 1,751,868 kilometers. In terms of expressways alone, China's National Highway System (NTHS) had a total length of 45,000 kilometers at the end of 2006 and 60,300 kilometers at the end of 2008, second only to the United States' 90,000 kilometers in 2005. However, as of 2017, China has 130,000 kilometers of expressways.